Hello, everybody. So, this actually starts module 7 in an 8-module class. So we're getting really close to the end. This week, next week, following Monday, and then after that is spring break. A week off is always really nice, especially after weeks of working hard at all our courses. Y'all have earned a break, so not too far off. And I kind of like to front load courses, especially these classes like this where there's a big project due at the end. Try to put most of the content towards the front, so when we get near the end, we can focus on the projects. Now that we've learned all that stuff, and have a little more time for that. But also, classrooms are very restricted on time, so we can't fit everything in there anyway. There's some other things that I always give you the list of odds and ends and stuff to go over. So that's what I had in mind for today. There's some stuff related to the module homework assignments, but they're kind of straight out of the book. For the most part, we're gonna focus on one thing out of there, which is search engine optimization. When a search engine finds our sites, how do we get up at the top of that list? We don't want people to have to scroll and scroll and scroll all the way down that list to find our site. We want to be up near the top. So that's included, but otherwise it's mostly like reading conceptual questions on quizzes and stuff. Should be fairly straightforward. And I want to start looking at not quite the list of odds and ends today. Is one thing I like to do with this class is, since we usually have a little bit of time to spread out our discussions in class when we get near the end here, I like to use this class as sort of an introduction to markup languages in general. It's a very common thing, and this class is where we focus on that one, where there's a standard, but there's some other ones that are very heavily used, very, very prevalent. I added a new one to the list this time because it's growing in popularity. We might get there today. That might be the next lecture. It's down at the bottom of my notes for if time, SSML, SVG, and LaTeX. But first off, I want to look at one of the most popular markup languages out there. So kind of stepping aside from XML, but also we need this to talk about, we need to know about this to talk about search engine optimization here in half an hour or so. So I want to talk about another markup language called XML. And this is one you'll probably encounter quite heavily if you're heading into software development. I move this. There's some little case there that I keep bumping whenever I come up there, and it's like a soft case. I'm like, I hope that's not anything anything fragile. So I keep stepping on it. Probably a better idea to move it out of the way. So this stands for Extensible Markup Language. So my notes, I put, we've been looking at HTML, the markup language standard used for websites, but not everyone required to take this class has plans to spend your working career making websites, right? You probably have something else in mind when you say software development. So part of the reason for learning this is just an introduction to markup languages in general for our other software development purposes. With HTML, we're looking at markup languages as data transfer, in particular for text and graphical data. Give our tags. We talked about it before. Markup languages are good for a CPU. Every piece of data has the data, the opening tag and closing tag, tell the computer exactly where that starts, exactly where it stops. In those opening tags with the attributes, we can add in metadata about our data. So everything's nice in a nice encapsulated form for computers to work with, but still human readable. So it's kind of a good crossing point for humans to work with there. So a similar one, not quite as standardized, but we often use is XML, especially for data transfer. Heavily used for data transfer. There are two of the two primary languages we use to transfer data. One of them is XML, the other one is JSON. They have different advantages. There's an efficiency issue that we don't really care about much anymore. Both of them, we haven't really talked about JavaScript. We saw that brief introduction to it, where JavaScript, the HTML5 standard for working with websites written in HTML, it's designed to go with a markup language. So when we pass other types of data in particular other markup language type of data, the JavaScript can work directly with that. It's just a different type of document than we normally work with. It's not the default document for JavaScript, but it is the sort of language JavaScript's already set up to work for or work with. And our other one that's pretty much standard for transferring data is JSON, JavaScript Object Notation, which is JavaScript directly. So what has become our two standards relate to one of the HTML5 standards. But there's an entire class on that language, so we haven't seen that much. But I want to talk about XML some. They both have their different advantages, but not significantly more advantageous than the other. There's just some slight advantages in there. So really it comes down to personal preferences for a programmer. Now that efficiency isn't an issue anymore like it used to be. Computers have gotten faster. There's still plenty of things we can do to bog computers down though. There's still a lot of big questions we can ask. So anytime the developer can buy back some efficiencies, it's a good idea to do so as programmers get bigger and bigger and bigger. And XML is one of the places that we do that. So the other big use for it is to buy back efficiencies in inefficient programming languages. Some of y'all may have had another class where you talk about object-oriented programming, which is really, really good for the human. It was developed back in the 1960s, but it couldn't really be implemented until the 1980s. And back in the 60s, some people in Norway came up with the idea, or really one guy came up with the idea, a team worked on it, and Norway's supercomputer got, for the 1960s, ran it no problem. But it was another 23, 24 years before the average computer could handle the extra overhead that comes with object-oriented programming. It's better for the human. Really what it comes down to, I like to just make up a number to write down as I talk about this, but you think of it this way. So object-oriented programming, it's better for the human, like way, way better for the human. So the programmer can do 1,000 times more at a 10% loss in efficiency. If we do that math, you can see we're still way up. So I just made those numbers up, but it's along those lines. The programmer can do so much more and we only lose a little bit of efficiency, it'd still be nice to buy back that efficiency when we can. So XML is commonly used for non-dynamic issues with object-oriented programming languages. I'm going to abbreviate that. So object-oriented programming, and then I follow, obviously there's lots of ways different people do things. I follow the convention to add an S at the end of object-oriented programming, and that way it makes a common word. So we can, the things that aren't going to change, in particular, are user interfaces. So those who are getting the software development degree, you're gonna have to take mobile app development at some point, and your interface for, take the Android version, your interface is written entirely in XML. So it's regular, and then the back end is, you'll probably write it in Java, but when we do it for Android stuff, there's translators there, so it actually translates to the language we want it to be in eventually, which eventually needs to be in Kotlin before being compiled, but any other strictly typed arbitrary language we automatically translate that. That's just parsing the text file and replacing words and symbols, other words and symbols. Any of your scripting programming language sort of classes probably covered that. So you'll see that in a lot in the mobile app development course with the graphical user interface for the mobile apps together. That's not the dynamic part. Once we create a button, we get a button and we put it on the thing, and then put it on the app, and that button itself doesn't change. It's when we push that button and it calls some code in the background, that code in the background is the dynamic part that needs the more complicated language. The stuff on the interface isn't really changing. So it gives us a way to buy back inefficiencies we lose elsewhere. It's not a new thing, all the way back to the creation of the Java programming language. There's a something called beans, which are written in XML. Anything from our program that we can translate to XML, we can pretty much automate that process of Java and working in Java. And that goes all the way back to the 1990s when efficiency was a big deal. So we always wanted to buy back that efficiency. The other most popular one we would be working with these days, if we had to worry about it, C#. It uses a very similar one. We would do a similar thing with a language called YAML, which again, is there two M's in that? Yeah, two M's. Just like C#, it's a Microsoft thing. It's one of those things stands for Microsoft markup language, Microsoft's markup language. But it follows suit with XML. I put pull up a beans example. I don't think I have any of those handy to look at. Actually, I might. Let me look at GitHub real quick. I'm going to share my screen. I might have something I get out for Android if I look through there. Probably don't though. Usually when I'm ready to release things, I move it off of GitHub. GitHub's all the working stuff and personal stuff. But maybe there was something Android left on here. Oh, this is Android. Okay, yeah, so here's the interfaces for this little phone app with time killing games, things that meaningless games, the sort of thing designed for like a waiting room. When you have to sit in the waiting room for 15 minutes and don't want to just stare at a wall or read a 25-year-old newspaper. Little pointless games like that. Play with one hand. But this is for the screen, and we're getting ready to talk about XML, but this is the interface for it. Instead, all the game stuff is written in Java here, but the interface where the buttons are, where it displays at, all the fonts and things, some of that should look somewhat familiar. Might not recognize the tag names here, but you can tell those are tags with lots of attributes in it. Tags with lots of attributes. And notice that the idea from markup languages like we've been looking at. What else was in the resource? Have any fonts? Or do they have any fonts? Or just a general menu. Again, you'll recognize from the angle brackets and attributes that it's a tag. The tags for markup language, similar to what we've been looking at, just not the HTML ones. Yes, I wanted to look at a quick version of that, and I think the next thing in my notes is to kind of put some together and talk about the data transfer process. So that one you will definitely see in your SDEV 264 class, because it's important to buy back efficiency on mobile devices. The way they operate, they use more RAM. So if you aren't aware of it, your like Android devices will constantly have to shut down and restart. But they work that in. There's some sneaky ways worked in there so that hopefully the user doesn't notice when it shuts down and restarts. But there's a lot of stuff going on there. On Android, our apps can use other apps. So they cut down to making smaller things, a bunch of advantages. That's a different class. But there's constantly stuff going on in memory, so it constantly gets overloaded. So it's very, very important to buy back efficiencies every chance we get. Even with some of the bigger, nicer phones these days, we still bog it down very, very quickly. Just because of the way it runs. So the example I wanted to look at was, let's take a look at the data transfer. I mentioned this the other day when we were looking at random things and the stock market data. We get that from only a couple places around the world. But here in America, we get it from NASDAQ. And they send out what's called an RSS feed. Really simple syndication, which is just an XML file. And then when we get it, we can kind of parse through that data and do stuff with it. So I'm going to actually type some stuff like we've been doing the whole semester, and then talk about another point that we haven't seen so much, but it still applies to HTML stuff. Where's one thing I was just looking at? So you'll notice right up here, this tag indicating the XML. So all of our XML files, we want to start with that. State that it is an XML file, so the machine will recognize it. What version of XML we're using, and the encoding scheme, which is probably Unicode 8. So kind of a copy and paste from that every time. So you always want to start with that, just like our doc type declaration for websites, which I haven't been typing in the last few examples. Or maybe they have. I think if it's in the automated predictive text thing. I've still been typing it, but just like the dot type declaration, we have to tell the machine we're working with XML. So first thing I'm going to do is change some colors. New folder, merge to. That'll work. I'll call this people.xml. So we'll look at the idea of data transfer. For those who have had me in class before, I have sort of a standard classroom example database sort of table, data organization scheme. Put it on the board like a table, just in case some of y'all may not have seen one I used in class before. So for like a database example, if we had a table filled with lots of different rows and columns, I only use 3 columns in my example. Lots of different rows. My standard example of 4 columns has to do with people. So a generic example, every person is going to have a name, an age, a town that they live in, and then a favorite food is sort of the example. And then we can fill it up with different rows of people. Like for me, an age, a name and an age. I live in Clarksville, which I did not leave enough room up here for. Favorite food changes. I'll put steak on there for now. Or but just some generic classroom example data. Since I'm talking about data transfer, I'll do that. So maybe we have a database table full of this stuff, and we need to get it from a database on a server somewhere to our website to show to people. That's a very common use for XML. So I'm going to talk about it here. But it's a popular programming language, kind of related to what we're studying here. So if we look at this class as sort of a introduction to markup languages. So I just typed the letter X once the text editor knew that it was working in the XML encoding language. And it threw up that first tag. So the question marks are important. Those do mean something to a computer. We saw them briefly with the PHP tags. But for our purposes today, let's just make note that they are important. And then we start consolidating our data, only instead of the table format like I drew here, we want to use markup tags like we've been seeing all semester to categorize that data. So we'll have different tags and nest things inside of it, just like we've seen. So overall, there's an overall tag. So just like we've seen with our HTML, right? We have that doc type declaration at the top. Then we have the HTML tag. It opens at the beginning and all the way down to the file. We close the HTML and everything in between is HTML. So the first thing we want to do is the overriding category for our data. It's not HTML this time. I'm just going to use my generic classroom example data of people. And then each thing on the list, the individual form of person, singular form of people, which I just made that word up. So HTML5, there were finally standards. There were a few things that we could count on browsers knowing before then, but HTML5 made it a really, really long list of tags that the browser had to memorize. that every browser had to know about. That whole standardization. But we can make up tag names, and then XML, we typically do just make up the tag names. So each person's going to have some stuff that we would, again, wrap in tags, just like we've seen. I'll just put my data on here. An opening tag and closing tag to throw that on here. Age 43. And then Clarksville. And then I'll go ahead and do favorite food. Favorite food of, I don't know, whatever. I think I put steak on the board. So you can see it follows suit with what we've been studying with as far as the markup language portion. We have those opening and closing tags, the data in between, standalone tags, add in attributes if needed for that, and organize our data that way for transfer. So I'm just going to copy that and put, I don't know, maybe two more. I'll just make up a couple names. So for the second one, Sally, who's 21, lives in Salem, and likes tacos. For Alan, who's 78, lives in New Albany, and eats pizza. So hopefully that's making sense. Just a way to, we use a markup language to track all of our data instead of putting it in the rows and columns like a table or some sort of mapping structure like a JSON object. Might glance at one at some point. But we use markup tags to identify what each particular thing is. And all the terminology we've seen, the parent-child relationships between the elements, from the opening close to the opening tag to the closing tag, everything in between, that's called an element. And any elements nested inside other elements are a child of that parent element. So all the terminology we've seen still applies. You can add some other stuff. For the generic example, like here, I can't think too much, but we could specify that how we're measuring this. So measure age in years, that's pretty common. But maybe Alan here is not 78 years, he's 78 months. That's not unheard of, right? Only 78 months, that's 5.5 years. So yeah, a 5-year-old probably like pizza. A lot more than a 78-year-old pizza. 78-year-old probably gets heartburn just hearing the word pizza. But our stuff with the attributes and the markup tags and all that still holds. So hopefully it all looks familiar there. It's a standard way to transfer data. Because of advantages we've talked about. Like this piece of data, this one. This piece of data, when that goes to the CPU, well, to begin with, it's in human readable form. Then when we pass it into the CPU, that data includes where it starts, where it stops, and some metadata that might be relevant for it. So it's a really good form to work with because it's good for both the human and the machine. That's the reason it's one of the standards for transferring stuff. And with the HTML5 standard, we haven't looked up much of it. JavaScript is made to go with markup languages. And this is a markup language, so JavaScript is already made to go with this and deal with the tags. going to the browser, but I was going to go here first. You can see here, my local computer's not quite sure what to open that with. A few different things. Where's my open button? There it is. I'll look right over. Okay. I'm just going to copy the address. Microsoft's being difficult. Wants to open that with Edge. And once again, they you can't even uninstall Edge on Microsoft 11. That's inconvenient. I don't need a bunch of browsers. So here we got the generic directory. That's kind of interesting, right? The browser recognizes the language enough to give us an error message. That's might be a little bit unexpected, right? So that's not the language we usually think about in browsers. So where's our error? On line 2, column 6, the XML declaration is only allowed at the start of the document. Which that's actually a better error message than some of the things we get from the actual HTML5 standard. So line 2, column 6. It says, oh, a doc type declaration is only allowed on line 1. We can't put a doc type declaration on line 2. We haven't encountered that because in HTML, the white space is automatically stripped out before it gets to the browser. So if it's on line 2 in the HTML, it'll be stripped out. Oh, so this one's just a typo. Line 5, column 39, opening and ending tag mismatch. What line did they say it was? Line 5, column 39. Oh, that's supposed to be the age tag, which that's the one I copied and pasted from. So all of them are going to be off it, aren't they? Yeah. So try fixing those typos. There we go. And so it shows on there, but you'll notice that big message up there at the top of Google Chrome. There doesn't seem to be a style language, but here's the data. So it can at least show it to us. Formats it nicely too, right? With where you can collapse the data, get it out of the way, look at it. And then for those who have seen other scripting sort of languages, dynamic scripting languages, we would just put together a selection structure to kind of parse through there and look for the tags. There's also libraries built to look for tags explicitly, but it's not difficult to just search for them. Somehow zoomed out. Which brings me to another point I want to do here. So if I delete that white space, actually, let me save a copy of that. Save as -2. And here, I'll get rid of that white space. That's probably enough. Obviously, the same thing's going to happen. That's a lot of going back and deleting. But if we just had a script read from the database, concatenate in a bunch of tags, it's probably going to look more like this, right? It's not a big long string that looks like a mess. If I come over and open that with the browser, people -2. Oh, that's not where I saved it. Oh. There we go. I'm gonna say it was an XML file. Oh, the browser's not gonna read it if I don't have the extension. Which I can save as people2.xml. There you go. So on that one that I just took all the white space out of, you see when it goes back to the browser, it's recognized and the browser puts it in that nice form. That's actually called pretty print. I'll write that word on the board. Because when you start doing things like retrieving data from a MySQL relational database and trying to get back to your web page, your script's probably going to produce something that is just like one long string of either XML or JSON data. That it's really, really hard to work with. So most of the libraries, not all, but some of them have what's called pretty print options. So when you go searching for libraries, if you want it to look nice with all the indents and tabs and stuff, make sure you include that in the search for it. There's a lot of options out there, which is another thing I always like to show with this part when we're talking about XML. I'll go back to share the screen again. I'll go back to Git. I know I have some stuff on Git related to this. What do I have on here? Oh, this work. So just for my IoT projects, it's like some starter files. Maybe a template. You say it's a template because there's a whole lot of time that has to be spent just for setup stuff, creating the database on the internet somewhere, and creating the local files that have the right names to access the database for all the different machines and devices, and a whole bunch of setup just to tie everything together. So I put a lot of that into a sort of template thing. I guess so. Whenever it sends something, no, that one doesn't compare. I was looking for something that actually gets stuff from the database. Translate plan, that might. Ah, here we go. So if you've had a DBMS class, you might recognize the SQL statement turned into PHP. We looked at PHP. Did a brief introduction for it, but we run that SQL code to get stuff from a relational database back over into a local script so we can work with it a lot better. And in this case, we want to send it to another machine. This is the web page controls, or would also be received by a mobile app controls for whatever the IoT device is. But this is going back to that, which means we probably want that sent as XML data or JSON data. Those are two standards. I usually also go ahead and include CSV, and if it's something that needs where security is a big deal, I like to come up with a custom encryption scheme. That way I'm not using, before anybody can even begin to crack the scheme, they have to figure out what the custom encryption is. There's one more step of cracking. The custom encryption that's been encoded, or a custom encoding that has been encrypted is like at least one step harder to crack. So if that's necessary, I can do that. But the standards up here, that's how I create a big XML file. Notice it's built into the library, and we just define things based off of the tree structure. So that one we were just looking at. Oh. -2.xml. So there's a tree structure. That's why we can kind of collapse everything. So the root of the tree is this people element. And when we expand that, there's different branches. That people element in this example has 3 different person branches. And the person branches have 4 leaves on them. That's our term for it, just like a tree. A root at the bottom, and then branches, followed by more branches, and then there's nothing else nested inside of it, then we call it a leaf. It's like a tree at the very end of all the branching. So our languages are set up to do that. So we create a root, and then we just add elements onto the root. So we don't necessarily have to do all of that typing ourselves manually. That's the common way to work with it. Oops. That will not result in pretty print. That's for data moving from one machine to another. If a human's going to work with it, we might want pretty print, which a lot of our programming languages have some to work with. This one won't. The Python programming language, however, does not have a pretty print in any of the official libraries to just add XML tags on, or HTML tags, or any markup languages. And in that case, it gets a little messier to do, but oh, there it is. So here's creating a string, adding all those tags in, and at least some of y'all hopefully recognize the \n and \e tag for new line and horizontal tab. That's how we type that. So like saying in Python, we have to write all that stuff together. We only have to do that once. And then we just tell it what the data is, and it'll write all those tags for us. And in the long run, what we've been doing this semester will be like that for HTML. I just thought I'd use the XML as the example to show that, but even our HTML will follow suit with that. We have other code write the HTML. Or maybe we just put the words we want on a page and have another script read that and add in all the tags, because it gets to be quite a mess. Putting in those tags, right? The more we have to type those, the more chance there is for a typo to happen. Computers don't make typos. So normally we would have computers write all the tags, but this is the pathway to learn to make software like that. So before we can write scripts to write a bunch of HTML tags around some various data, we kind of need a pretty good familiarity with HTML. That's what this class is about. CSS is a little bit different. CSS is available in almost all our languages too. It's becoming across the board thing. So that's sort of just some general notes about XML. Obviously not our only one. I've put 2 up here because anymore in our modern world, If we go to write a program, we're probably going to use Python because that's the easiest thing to program in. But the reason that I had to wait till that took so long to take off is Python has always became well known very quickly for being the easiest one to work in. But Python is a much slower language. It's terribly inefficient. Python's like a cruel thing to do to a machine. That's like all what running code written in Python is like what all those science fiction horror movies you talk about when they say humans mistreated machines. Probably gave them a bunch of Python code to run. But it's easier for the human. It's terribly inefficient and slower. So when we start worrying about that stuff anymore, you're probably going to use Java or C#, which are more efficient, but they're object oriented, which in general is inefficient for a machine. So we use markup languages to buy back any inefficiencies we lose. But the biggest use for it by far is probably transfer data. And that relates to the next thing I wanted to talk about. Leading into one of the topics, it's actually a label on the course module this week, and that has to do with search engines. We want our websites to show up on a search engine, right? So I goes, just looking at the list of names on the screen here today. For example, one of the class projects is about Star Trek fan site. And well, especially the person working on that, you're probably well aware there are lots of Star Trek fan sites out there. And Star Trek fans do go and look at each other's sites and have discussions and include fan sites in part of what they're as part of the general enjoyment of the show. So probably want that site to be found when somebody goes and starts Googling things about Star Trek. You know, maybe not the very top of the list, be somewhere on the list. We'd think that the Star Trek TV shows and movies would be at the very top of the list, but be somewhere near the top. So we need ways to do that. And search engine, in order to find all the stuff really quick, you can't scour the whole internet instantly. Right? It has to already know in advance the current state of the internet, basically. So to do that, those search engines, really Google, I'll just say Google. A similar thing would apply, we're going to talk about, would apply to other search engines, but we're going to use Google for the example here. So I'm just going to say that, but all the similar things would apply. The only difference is we would go to like different websites to set things up. But Google needs to know about the current state of the internet when somebody goes to search for something. And it can't scour the whole internet immediately, right? That's a huge process. It's not even the current internet. There are numerous places around the world that completely back up the internet. If you didn't know, if you hadn't heard this, I remember one it made me really happy to learn about, and I never have quite figured out the right words to express, to put on it. But the public library in Alexandria, Egypt, is one of the places that backs up the entire internet every 72 hours. I haven't quite found the right words, but with the history of Alexandria, it made me really happy when I learned that. So we can search that too, which takes more detailed searching, and that's not the only place that does it. But there's that, and the current state of the internet, and it backs it up every 72 hours because it changes. There's constantly different things happening. So to keep track of it, or have a really good idea of what's going on with it, Google sends out bots, just pieces of software that just get transmitted across the internet and collect information about it, and then report back to a central server, so that when somebody asks that central server a question, it can direct them to a spot on the internet where the bots spotted that stuff. Basically, just small pieces of software that can follow links. So the first step when we want Google to know about our websites is make sure that the bots can navigate around our websites. So to do that, we need a sitemap. I have any notes to put on the board? I'm just going to jump right into doing this. So to do that, we could type it up. It's an XML file, but we can also we can automate the process, which is probably what you want to do anyway, right? I want to type all those tags. Want the computer to type the tags. We're humans. We want to deal with the data directly and let the computer handle all those little details, like the opening and closing tags, all of that stuff. Avoid typos. Making typos is a human quality. Machines will make typos. If a machine makes a typo, it's because the human made a typo before debugging that software. So what I usually do is just go to Google and search generate sitemap. Our mapper, I haven't used that one. This is the one I usually use. XML sitemaps generated. But something else has moved up above it, so maybe that's a good one. I need a site for a map to map. Well, that's not it. Somewhere near the beginning of the semester, I think we did a class example that had at least 2 pages. Oh yes, this has 2 pages. So basically what the bots are is they're things that go out here and follow these links. Seems to be an error on there. So there's at least 2 pages there. So I'll use this URL. Take it back to the first page. Copy that. Just paste it in there. And this sends out bots. Goes over there. Looks at every link on that page and clicks it. Goes to wherever that link goes to. Clicks that link and just follows all the way through. Clicking links and getting the whole thing together. We have to go to view details. Then view details and download it. So here's what a sitemap looks like. We just looked at XML, so that declaration up at the top should certainly look familiar. And then we have a URL set, which is right like the name implies, the set of every URL that we can access from that page. Or that looks like it's where we got it from. Oh, that's looking for the official stuff. Okay. I just stared at those addresses and tried to figure out what those were about. So that's all of, so the first one is where we got that from. The second one is the standards, the W3 consortium standards. Then the full location of the sitemap is stored here. And yeah, just different information about it, where to get it, and then the link to our site in particular. So you can see it's just an XML file filled with a bunch of links and details and things. So we need one of those. So yeah, there should have been 2 URLs. I don't know why I didn't follow that, but it'll be fine. Basically, URL element as a location and last modification, last time the page was modified, so that our bots can follow all those links through and check out the pages and report back to Google what's going on. Yeah, I don't know why it didn't make the second page, so I'm going to go ahead and make it. So the second page just looks like this. What was it called? Go to page 2 is this. I'm pretty sure that page was last modified at the same time. So that's what a sitemap file is. See, it's very stripped down. Not really anything there for a human. So you can type that. Like I saw when that second one was missing, I had to copy and paste just copy and paste the URL and just add on those tags. But an easy thing to generate. And once we have that XML file, we need to put that on this site. So I'll log in here and basically upload it to the same place. Class 2 example. That was a couple weeks ago. But now that map, and just once you get the map made, put it on and put it there with your website. Doesn't necessarily have to be the top level. You can nest it a little, but remember the bots need to find it, and bots are pieces of software. They're not intelligent things. So just remember to make sure it's in a spot the bots will be able to find it, which has no effect on our actual page. The next thing we need to do is go tell Google we have a site for it to know about. Google.com, yeah. So you'll want to go to the Google developers page. I've had my Google account for so long, I can't recall for sure if this is part of the paid account or if everybody has access to this part of the page. It might be the part of that that thing that is a one-time $25 fee for Google. Right. Then under products, go to search. So you can see there's a lot going on here. So you might want to make a note. I'll pause for a second so you can make a note of that. Go to developers.google.com and then products and search. That's the one that's the page there's a lot of stuff to dig around on and find. Developers.google.com. Then if you go to the products option under search, you'll get to this page. Actually, look at this. The Get Started has a whole bunch of things that you're going to want to read. One of the chapters in the book this week is about search engine optimization. That's what we're going to talk about in a few minutes after the break. But that was written in that textbook a while ago. The notes I have here, I wrote in December of 2018. I've made some notes since then. I've updated them multiple times since then, because it's a dynamic thing. Our textbook, I know certain still says the exact same thing it did in 2018. It's a dynamic thing. So if you come on here, Google will, the default place it goes to is like instructions about search engine optimization. The things to optimize your website to score higher in Google searches. And this is where Google puts the list of those things. So instead of that textbook, obviously read the textbook because that's going to introduce it. But then this page is the dynamic, always up to date one for what Google wants. So when they change their mind about what their search bots are looking for, that's where you'll find it at. Where do I go? It's just basics. Then over here, it's hidden behind my pictures. If it's behind the pictures on your screen, there's a blue button that says go to Search Console. You click on that. Here's where we tell Google about this. Here's the domain we wanted to know about. Paste that in there. Oh, I think I have too much there. Oh. Remove protocols or paths. Oh, it wants the top level domain. So it only wants that part. In either one. Okay, there you go. You can see I guess we can't go to the subdomain. I thought I've used subdomains before, but it didn't seem to like it. What is this one? Oh, I just copied that. Can I copy the full domain here? Okay, the traditional one will let us do down to that specific folder on there. And I didn't pay any attention to that label to begin with. The one on the left is for the full domain, and the one on the right is for just something on that domain, a particular thing on that domain. I'll put that on there. So we need to download this file. Oh, the instructions are very clear. Download this file, put it there on that site, and then give Google 24 to 72 hours. So download that. Go back over to the file manager for our site. And went through that part kind of quick. Y'all have seen that. So we put the sitemap on there, but we also need that file Google gave us. I only recently learned I could do that. I've been seeing those things down at the bottom of the screen for years, and only recently learned that I could drag them from there into other places. I was like, wow, how did I never realize that? Because I actually learned that by accident. But even if you do it the old way, go your thing and just copy and paste or hit the upload button. Lots and lots of different ways, but the file Google gives us, we have to put that on there. I guess you could almost think of that as like a homing beacon for the bots. I've never seen it written down that way, but that's the way I think about it. I've never seen that actually, that terminology used, but that's what I think about for that file. It's something that something to attract the bots, maybe. And once we do that, Hit verify. And I'm not sure what the error message is about. Usually that comes through without problem, but something got a little off. Maybe it's blocked for some reason on that domain. Okay, so HTML5 might be blocked. So if it needs the provider, you can see it's very straightforward. They give you this file, copy and paste this over to the domain name server for your host. Which is in the control panel, the things we haven't looked at as much. Then down there is the domain name server, the thing that keeps track of all the names, connects all, yeah. Server that keeps track of all the names. We would just go in there and upload that file that they gave us. I think that's what that error message was, but I was just wanting to go over the general process. In the long run, you'll probably go ahead and pay for a domain. That probably sounds like it sounds bad while you're in school, right? The school's expensive, money's stretched tight. But remember, when you're out there making good software developer money, come tax season every year, you're going to have some things you can itemize on your taxes, such as business expenses and things like paying for really good domain sites and paying for good domain names. Those are business expenses for a software developer. So you write them there on your Schedule C, and they come right off of the taxes you owe after making that great big, huge, really nice software developer paycheck. So that's the general process. You can see Google gives you everything you need with detailed instructions right there on the thing. And on your way there, when you go to developers.google.com/search, this is where you go look for the most up-to-date version of the thing we're going to talk about after the break, which is how do we get our site to rank higher on there. So make a sitemap, upload that, then go get the file from Google, upload that, and then they say 24 to 72 hours. Give them 24 to 72 hours, and they'll send you an email that says they have got it mapped out and included. So a very easy process, well described here and everything. And the big blue button just goes right over to where you do that. That's giving some sort of error that I have not encountered before, so I'm thinking it has to do with the domain name thing. So it said the error message did say does not own the domain, so it's not a free domain. So I have to go down to that other one, which looks like it's just copy and paste that as an entry into your into the DNS they give you access to. So it should just be following those steps. But right after you graduate from school and get out into the world and are doing this, you will probably have a domain that you own and a domain name that you own. So we use free ones. Good names cost money. That's another thing we're going to talk about after a break. Looks like it's about time for that. And I just wanted to go over those processes because some of y'all have seen this from me before. That's definitely one of those things that was omitted from any class on my way through school. The point of being here is we want to make money with this stuff, right? We want to know how to do this stuff. And the classroom always just shows like the syntax for HTML and tell us what to do afterwards so that we can make money. so we can make money with that, so that we can make pages that show up at the top of the Google search results. I had to go figure that one out afterwards, so I had a long list of things like that. My plans were to be a math teacher when I showed up to teach software development. I was like, yes, I have a whole bunch of things that I would like to start showing people in a software development classroom, because I feel very strongly that they should have been included in some of the classes I took along those lines. But probably good enough for a break. 10 minutes sound good? Everybody or anybody? I see a thumbs up. So 2:13, we'll get back to it at 2:23. See y'all in a moment.